Hey everybody, welcome back, and if you're just checking out the channel for the first time, welcome. In this video series, I'm working on building a 3D SimCity clone using JavaScript and Three.js. So in this video, we're going to be working on giving our citizens jobs. So just to recap, in the last video, we worked on adding citizens to our city. Now we need to give them a place to work. So here I'm demoing the code where I've already completed that. And you can see that we have a resident in our building here named Noah Walker. He's 29 years old, and he's working at Elevate Ventures LLC. So if I click on any one of these industrial buildings here, you can see that this one is Elevate Ventures LLC, and the worker, 1 out of 4, is Noah Walker. When our citizens move into the city, they look for a job, and they look for a nearby industrial or commercial building that has a job opening, and then they take that job if it's open. So if I were to delete this building here, you can see that Noah Walker, he went and found a new job at Zenith Technologies. So you can see that he's now working with John Young at Zenith Technologies. So when they lose a job, when a building is deleted or becomes abandoned, they'll go and find a new job in the city. All right, so I've kind of showed you what we're going to be working on in this video, so let's get right into the code. All right, so we're going to be starting in our citizens file here, and we're in our create citizen function. So the first thing that we need to do is to scroll down to the properties for our citizen, and we're going to be adding a few new properties here. So the first one that we'll be adding is state, and this is going to be a string. So this will keep track of the current state of our citizen. So right now we'll only have 2 states. We're going to have employed and unemployed. Additionally, we also need a state counter. So this is going to be the number of steps in the current state. So the number of steps that they've been unemployed or employed. Finally, we need a job property. So we'll initialize this to null. So this will be a reference to the building where the citizen works. All right, so these are the 3 different properties that we'll be using in order to implement jobs for our citizens. So the next thing we need to do is go to the update method for our citizen. So we need to implement the state machine for our citizen. So let's write a switch statement here that switches on state. Now we always want to have a default in our switch statement to catch any states that maybe errors or we didn't account for. So we'll add an error message for that if the citizen is in a state that we do not expect or is in some unknown or undefined state. So how the state machine will work is that for each different state, we need to implement the action for that state. So what is the citizen going to be doing when they're in that state? And we need to implement the state transition logic. So we'll start with the action for the unemployed state. So they're going to be looking for a job if they're unemployed. So we'll do a quick console log statement so that we know that the citizen is looking for a job. So below here, we're going to write a line where the citizen is actually finding a job. So we have not implemented the find job method yet, but we'll get right to that. Before we do that, let's finish out the transition logic. So if the citizen has a job, then we'll log that to the console. So this person found a job at this.job.name. Then we'll change our state to employed. Okay, so we have the action for our state and we have the transition. Now we need to implement the actual logic where they go and find a job. So let's scroll down a bit here and we're going to add a new method. So how this find job functionality will work is that the citizen is going to start searching where they're currently living. That's going to be the search start point, and they're going to slowly expand their search outwards until they find a commercial or industrial building with a job. And at some point, they're going to stop that search when they get a certain number of tiles away. So we don't want the citizens driving all the way across the city to find a job. We want it to be somewhat of a local search to match reality. So this type of search is called breadth first search. So you can see an animated example right here where we're starting in the bottom right corner, and then the search field is slowly being expanded out to the upper left corner. So in each step, it's adding on the adjacent tiles to the search field. It's looking at those tiles, seeing if they match the search criteria, and then it's either going to continue the search on if it doesn't find anything, or it's going to stop and return that tile. So before we can actually start working on this function, we need to implement this breadth first search functionality on our city. So let's go back to our File Explorer, open up our city, and let's scroll down here underneath our update method. Let's add a new function called find tile. So I've added some documentation to our find tile method here. So what this is going to do is it's going to find the first tile where search criteria evaluates to true. So search criteria is actually a function, and this function is called on each tile in our search field until it evaluates to true, or there are no more tiles left to search. Okay, so let's build out the implementation for our find tile function. So first we're going to need to define the starting tile. So we will get the tile at the x and y coordinates of our start. So next we need to keep track of which tiles we've already visited. Now for this I'm going to use a set. And the reason I'm using a set is because it allows for very fast lookups. So with a set you can look up in constant time, or if we were storing these in an array, then it would require linear time. In the worst case, we'd have to search through the entire visited array before we found the tile. So we're going to be storing the IDs of our tiles in here. Our tiles do not yet have IDs. So similar to what we did for our buildings, we need to have an ID on every tile. So I'm just going to copy this, and then I'm going to create a new property on our tile called ID. Now we also need to keep track of the tiles that we need to search. So this is the boundary of our search. This is the tiles that are currently being looked at. And we'll initialize our search boundary with the starting tile. So we'll just push that on to tiles to search. And now we need to loop over all of the tiles in our search boundary while there is at least one tile in that array. So when we look at the next tile in our search boundary, we'll pull that off using Shift. So Shift removes the first element from an array and returns it. And if the array is empty, undefined is returned and the array is not modified. So we always know there's at least one tile in the array. And then we need to check if we visited this tile or not. So if visited has the ID of our tile, then we're just going to continue on to the next tile in our tiles to search. Otherwise, we will add this to visited. That way, next time we visit this tile in a search, it's going to trigger this branch of our condition here. So the next thing that we need to do is to exclude any tiles that exceed our max distance that we've defined. So we need to calculate distance here. And we need to calculate the distance from our start tile to the tile that we're currently looking at. So I think it makes sense to add a little helper function on our tile. So we'll add a method down here called distance2, and we'll pass in a tile. And we're going to use the Manhattan distance for calculating distance. So the Manhattan distance, the name is kind of based off of the different city blocks in Manhattan. So the distance is summing the difference in the y and the difference in the x and then adding those together. So the red, the blue, and the yellow distance all have the same distance of 12, which is the shortest path length. So if we kind of think of how our citizens would travel to work, they'd be driving along roads, they'd be taking this sort of stair-step approach to get to where they need to go. They're not birds, they can't just fly over to where they're going to work, so it makes sense to use the Manhattan distance for calculating that. So in code, it looks like the following here. So now that we've implemented our distance function here, we can close that out, go back into our city, then we'll do distance to tile. So if the distance is greater than the max distance allowed, then we will continue on to the next tile in our search criteria, or excuse me, in our search boundary, So we'll evaluate our search criteria here and we'll pass in our tile. Now if our search criteria returns true, then we want to return that tile. Otherwise, we want to search all the neighbors of this tile. So in order to get the neighbors of the tile, we need to write another method where we pass in x and y coordinates, and that'll give us the neighbors of that tile. So I'll add an additional method down here called getTileNeighbors, and we'll pass in an x and y position. So I went ahead and wrote the getTileNeighbors function. But as I stated before, we pass in the x and y coordinates of the tile that we want to get the neighbors of. And then we basically just push on all the neighboring tiles. Now I'm not looking at diagonal tiles, I'm only looking at tiles that are to the left or to the right or above or below. So all I'm doing here is just checking to see that we aren't getting any index out of range exceptions. So if I were to pass in an x coordinate of 0 and subtract 1 from that, I would get -1. Obviously, there's no tiles in the -1 array position, so I need to just add some checks in there to make sure we're not exceeding the bounds of our game map when we're looking for neighbors. So now that we have our getTileNeighbors function written, let's go back up to this if here. So if our search criteria fails, then we want to add the neighbors of our tile to the search field. So at tiles to search, we will push, and we're going to do this expression here, getTileNeighbors, tile.x, tile.y. So we're going to get the neighbors of the tile, which is an array. Then we're going to use this destructuring operator here, which basically returns a sequence of the elements, which we can then push onto our tiles to search array. So finally, if we get through all of our tiles to search, and there's no tiles that meet our search criteria, then we're going to return null from our function. So now that we've finished our findTile method, let's go back to our citizen, and we will implement our findJob function now. So in our findJob function, we're going to be searching for a tile using our new findTile function that we just implemented. So the starting position that we'll be passing in is the position where the citizen is currently living. So we can actually pass in this house object, and in our findTile function, it will be able to pull the x and y coordinates from our tile. So we can just pass in the house directly. Now we need to define our search criteria function. So I'll create a new function there. So if the tile does not have a building, then we immediately know that this is not a tile that has an industrial or commercial building. Then we need to go ahead and get the building type. And if the building type is equal to industrial or commercial, then we need to check if that building has any jobs available. So if building has jobs available, return true. Now we currently don't have any sort of job functionality implemented on our industrial or commercial buildings. So let's go ahead and work on that now. So let's define two new properties here. We're going to create an array called workers, and we're going to have another variable called max workers. So the workers variable is going to be the array of citizens that work here, and this will be the maximum number of workers this building can support. So we need two different methods. We need number of jobs available. That will be our max workers subtracted by the current number of workers currently working here. And for completeness, let's do a number of jobs filled method here, and then we'll return the number of workers. So I'm going to go ahead and copy and paste these into our industrial building, just down here. There we go. So now going back to our citizens file. So if the number of jobs available on our building is greater than 0, then we're going to return true. So if any of this is not true, then we'll just return false because we don't want to evaluate that tile. So this will return a tile that either has a building with available jobs on it or will be null. So we need to check if tile is not null. Then we're going to add this citizen as a worker to the workers array. And then we're going to return the building that the worker is working at. Otherwise, we'll return null. Now we also need to handle the case where our citizen is currently employed. So there's no real actions that they need to take. They're kind of just working behind the scenes, but we're not simulating anything there. The transitions we need to handle if they lose their job. So the building could be deleted or abandoned. So if that building no longer exists, then that citizen will become unemployed. So if the citizen no longer has a job, then we need to set their state to unemployed. So we've written a whole bunch of code, so let's kind of start fleshing out the UI so we can actually see what our code is doing. So first of all, let's go down to the toHTML function for our citizen, and we're going to replace this with a bit more information. So I've replaced the previous span element with a list item, and that has a nested list inside of it. So all we're doing here is we're showing the name of the citizen, then we're breaking down into some more information, the age of that citizen and the job that they're currently working at. So our commercial industrial buildings, they don't have names right now, so we need to go ahead and add those. So let's just do a placeholder name for now. We'll replace this with a random name generator later on in the video. Spelling there. Okay. Now we also need to adjust the toHTML function for our commercial and industrial buildings so that they show the workers currently working there. So we'll go down to the toHTML function here and let's add in some code that will display the workers. Okay, so let's run through this code quickly. We're creating a new section here called workers, and we're going to show the number of jobs filled at this workplace next to the number of maximum workers. Then we're creating a list of our workers, much like we create a list of the residents for residential buildings. So if we have at least one worker working there, then we iterate through all of them, and we'll add the HTML for the workers. So we also need to do this for our industrial building as well. So I'll copy that and paste it down here. We need to make one final tweak to our residential building. Since the toHTML function for a citizen is no longer returning a span, we can get rid of this line item here and just return the result of the function directly. So if we're in our game now, and let's lay down a residential building, a commercial building, and an industrial building. So if I click on the residential building, we can see all of our citizens listed, and you can see that they are all unemployed. And if we look at our commercial and industrial buildings, we can see that there's no workers either. So let's go and look in the console, and we can see that our citizens are never looking for a job. And the reason for this is that we're not calling the update method on our citizens yet. We have not implemented any code that would call this. So we need to go ahead and get that working. So let's go back to our city file. And in the update method, after we update all of our buildings, let's go ahead and update all of our citizens. So for each citizen in our citizens array, we want to call the update method for that citizen. Be sure to pass in the city as well, because that's an argument to that function. So another change that we need to make is that we're passing in our house to the findTile function, and our house is a building object. So if we look at our findTile function, it's getting the x and y coordinates of that building. Now if you look at our building, specifically the residential building, it does not have any x and y coordinates. So we need to pass in the x and y coordinates of the tile to the building so that we can access those coordinates right here. So I'm going to go ahead and add that in. So when we do create building, we'll add x and y coordinates, and we need to pass those in to each of our create building functions. All right, so now that we've added x and y coordinates to all of our buildings, let's go ahead and make sure that any references to create building are updated so that we are also passing in these x and y coordinates. So let's do a quick search here for create building. And looks like there's one instance where we need to update this. So let's do a few more tests here. Let's lay down a residential building, and we'll do a commercial building. Make sure that they can find jobs in the commercial building. So it looks like that is working. Now I would expect if I add another industrial building here, it's not going to get any workers because all of the workers in the city have been taken by this other building here. But if I add another residential building, you can see that these people are also finding jobs, and they have found jobs at this industrial building now. So as we add in new different zone types, we can see that the residents are going out and finding jobs in those new buildings, and the jobs aren't being filled if there's no people to fill them, which all makes sense. So now that everything is working, it's time to add a bit more fun to this. Our building names are really boring right now, and we actually need to list them on our info overlay as well. So let's utilize ChatGPT to write some code that'll generate random names for our industrial and commercial buildings. All right, so we have ChatGPT open, so let's ask it to write some code for us. So right away it's spitting out some code. Looks like it's taking an array of prefixes and suffixes and then randomly picking one out of each and stitching them together. So we get like advanced solutions, integrated systems. So this is exactly what we want, but these names are a bit boring. So I think we also want an additional array here so we can append the type of company. So if it's LLC, Inc., Co., things like that, just to give it a bit more realism. So let's tweak our prompt a bit. All right, so this is pretty good. I think this will be good enough. You get some more interesting names like Apex, Quantum, Hyper. So let's just copy paste this code here. And then let's go into our buildings. And I think before we can use this code, I think this file is getting long enough. It's over 250 lines now. We need to refactor it a bit. So I'm going to break this into separate files for each building type and create a new folder to store all of this. All right, so I went ahead and did a quick refactoring of all that code. So now we have a buildings folder here. It contains our original buildings file. And I'm just broken down each of our create building X functions into a separate file. So create commercial building, industrial, residential, and road. So let's go into our create industrial building file now, and at the very bottom, let's add that code in that ChatGPT gave us. So we'll delete this test code here. I did notice looking at this, it duplicated industries, enterprises, and group. So I'm just going to go ahead and delete these, maybe add one more, like a limited company type here. So then for our company name, we'll just call generate company name. Now I also want to do the same thing for commercial buildings, so I'll ask ChatGPT to do that as well. And you can see these names are slightly different here. They're more kind of trading, commercial type of stuff, so there is some differentiation between the two. And then let's go into our commercial file, paste it at the bottom here, and delete our test code, and replace name with generate business name. All right, so we're back in our game now. I'm going to lay down a bunch of residential, commercial, and industrial zones. And it looks like I forgot to add the name of the building here in our info overlay. So let's go ahead and add that. So our commercial buildings, this one's called Supreme Market Incorporated. This one's Prime Emporium Incorporated. Dynamic Hub Limited. Infinite World LLC. And this Industrial Vortex Manufacturing Limited. Epic Innovations LLC. So we have some pretty cool names now, I think, for some quick AI-generated code. All right, so there we go. Our citizens are now able to find jobs. They search the nearby area for jobs, and we're able to kind of view that within the UI here now that we've updated the info overlay. So the one last thing that we need to do is, let's say we deleted all these commercial and industrial buildings. Our residents still think they're employed at these buildings. So we need to create some type of trigger that when we delete an industrial or a commercial building, it will go ahead and clean up kind of its state. It'll go through all its workers and tell them, hey, you're fired, you don't have a job anymore. So I think that's the last puzzle piece to get this working. So in our commercial building file here, I'm going to add one more method called dispose. So for each worker in workers, worker set job to null. Now this method does not exist on worker, so we need to go add that. And I'll add that right below find a job. Let's go set job, job, this dot job equals job. So we also need this on our industrial building. So add it there. And we need to make sure this is this dot workers. So we want the workers property on our object. Forgot that here. And we need to make sure that this dispose method is called. So remember that in our tile, we created a remove building function. So if there is a building, then we want to call the dispose method for that building. So let's lay down a couple residential zones here, and I'm going to lay down some industrial zones right next to them. So you can see that all of our residents are currently employed at these various businesses. These residents here work here, so if I delete this building, we would expect that now all of these people are unemployed. And everyone else is unemployed because their building still exists, so if we delete those, you can see that they now became unemployed, and now all of our residents are unemployed, which is exactly what we want. So I think we have the same issue with our residential buildings as well. Looks like we're actually having some issues deleting them, and that's because we forgot to define dispose on our other buildings. So let's make sure we add that first. So for our roads, this isn't going to do anything, it's just going to be an empty method. And our residential building will be the same. Dispose method will not do anything. So now if I go and add some residential buildings here, I should be able to delete them. So you can see one issue is that our population is not being updated. And that's because if I close out of all this here, just to kind of clean it up. So if you go to our city, our population is being calculated by looking at our citizens array. So we're not removing the citizens from this citizens array when our residential buildings are bulldozed. I feel like we should dynamically calculate the number of the citizens in the city by just looping through all the residential buildings and summing up all the people that live there. So what I'm going to do is I'm just going to delete this, and then I'm going to update and get population so that it loops through all of our tiles and sums up the total number of residents. So I just wrote a quick for loop here. So we're starting with initializing our population to 0. Then we're just looping through each tile. And if that tile has a residence property on it, then we're going to get the number of residents in that array. Otherwise, we'll return 0. Then finally, we'll return the population. So we can remove this line here in our residential building object. We no longer need to add it to the citizens array. All right, so if you go back to our game, lay down some residential buildings, watch the population grow. And if I delete a building, you can see that our population now adjusts accordingly. So in the next video, I haven't quite decided what I'm going to work on yet. I think it might be road access. So now that we have a find tile function, we can actually introduce some logic so that when our buildings are not next to a road or within a few tiles of a road, that building will not grow. So thank you all for tuning in. Appreciate the support. If you have any ideas for additional features to add into the game, please let me know in the comments. And please be sure to hit that like and subscribe buttons. Until next time, take care.